Welcome, everyone. Today we are focusing on configuring access to Azure storage, specifically diving deep into stored access policies. Let us get started and learn how to secure your data effectively. Before we can understand stored access policies, we must first understand the limitations of standard shared access signatures. A SAS token is an incredibly useful URI that grants restricted access rights to your Azure storage resources without compromising your primary account keys. The basics of a standard ad hoc SAS token dictate that its access parameters, such as the start time, expiry time, and permissions, are baked directly into the token itself. Why is this a problem? Because once that token is generated and distributed to a client, you cannot change those parameters without generating a brand new token. Taking a deep dive into security, if a token is compromised, the only way to revoke it before it expires is to regenerate the storage account keys or delete the blob entirely. Regenerating keys can cause massive outages for other applications, which brings us to our main topic today. Let us look at this flowchart to visualize the risk of ad hoc SAS tokens. At the top, we have a standard SAS token which contains hard-coded embedded permissions and an embedded expiry time. If we follow the flow down to a scenario where the token is compromised, the administrator is forced into a difficult corner. The only remediation path is to regenerate storage keys. As the final red note highlights, this leads to a high risk of application downtime because any other service relying on those keys will instantly break. We need a better way to manage this access. What exactly is a stored access policy? By definition, it is a server-side configuration that allows the access parameters for a SAS token to be completely decoupled from the token itself. For the basics, instead of putting the permissions and dates into the URL, the policy securely specifies the start time, end time, and access permissions independently. How does this work in practice? When you generate your SAS tokens, you simply reference the stored access policy identifier rather than embedding the parameters explicitly. Diving deeper, you can think of the stored access policy as a centralized security template. The token becomes nothing more than a pointer back to this policy. This architectural shift from client-side embedding to server-side referencing completely revolutionizes how we manage storage security. This left-to-right diagram perfectly illustrates the decoupled architecture. The client application uses a SAS token URI. However, notice that the token itself does not contain the permissions. Instead, it references an identifier pointing to the stored access policy on the server. It is the stored access policy that actually defines the permissions and the start and expiry times. Finally, the policy evaluates the request and grants access to the Azure storage resource. This separation of concerns is the core concept you must grasp. Why should your organization mandate the use of stored access policies? The primary reason is administrative control. Because the token points to the policy, the parameters of existing tokens can be modified by simply editing the stored access policy on the server. For business continuity, this is incredible. If you need to extend a vendor's access by a week, you just change the expiry date on the policy. Existing SAS tokens remain perfectly valid and seamlessly use the updated parameters. Most importantly for security, if a token is leaked, you can revoke it instantly by altering the policy, entirely avoiding the nightmare of regenerating your storage account keys. This deep dive benefit means you gain an enterprise-grade revocation mechanism while protecting the uptime of your storage environment. Let us walk through a real-world sequence. First, the storage administrator edits the expiry time directly on the stored access policy to extend a partner's access. Instantly, the active SAS token automatically inherits this new expiry time. As the note highlights, there is absolutely no need to generate or email a new token to the client. Later, if there is a security breach, the administrator deletes the policy. The moment the policy is gone, the token is instantly revoked and access is blocked. Before we implement these policies, we must understand their scope and limitations. For the basics, stored access policies are exclusively designed for service-level SAS tokens. This means you can attach them to individual blob containers, file shares, queues, or tables. However, there is a major constraint to memorize for your exams. Currently, stored access policies are not supported for account-level SAS tokens. Another strict platform constraint is the quantity limit. You can have a maximum of only 5 access policies on a container, table, queue, or file share at any given time. Diving deeper into architecture, because you are strictly limited to 5 policies per resource, you cannot create a unique policy for every single user. Instead, You must design your access strategy by grouping users into logical buckets, like a read-only bucket and a contributor bucket. This mind map summarizes the strict boundaries of stored access policies. Branching to the top right, we see the supported scopes, which are exclusively service-level resources, blob containers, file shares, queues, and tables. Branching to the bottom right, we see the unsupported scopes, most notably the account-level SAS. Finally, branching to the left, we highlight the hard limits, reminding us that we can never exceed a maximum of 5 policies per resource. How do we actually create a stored access policy? You can easily achieve this using the Azure portal or Azure Storage Explorer. In the Azure portal, you navigate to the specific storage account, open the target container or file share, and select Access Policy under the Settings menu. Alternatively, in Storage Explorer, you simply right-click the container and select Manage Access Policies. The basics of creation require 3 elements. You must provide a unique identifier string to name the policy, define the exact permissions such as read or write, and define the start and expiry times. Here is a deep dive tip. If you intentionally leave the start and expiry times blank within the policy, you maintain the flexibility to specify those particular time fields ad hoc when you generate the SAS token, while still locking down the permissions centrally. This flowchart traces the exact click path for creating a policy in the Azure portal. You start at the storage account, drill down into your specific container or file share, and click on Access Policy in the Settings menu. From there, you click +Add Policy. The configuration steps require you to define the identifier name, select the specific permissions, and define the start and expiry time. Finally, you save the policy, committing it to the Azure platform where it waits to be referenced. Once your stored access policy is created, the next step is linking a new SAS token to it. What this means is generating a service-level SAS token that references your newly created policy instead of using manual inputs. How do you do this? Whether you are using the portal, PowerShell, or Storage Explorer, during the SAS generation process, you simply select your stored access policy from the designated drop-down menu. For the basics, you will notice that the moment a policy is selected, the manual permission and date fields in the interface become locked out because they are now entirely governed by the policy's rules. Diving deeper into the actual URI string generated, the resulting SAS URI will contain a special signed identifier parameter, usually denoted as SI equals. This SI parameter points directly to the policy identifier name you created, completely replacing the explicit permission tags in the URL. Let us trace the generation sequence. The administrator initiates the generate SAS command in the tooling. Crucially, in step 2, they select the stored access policy from the drop-down menu. The tooling immediately locks the manual permission and date fields to prevent conflicts. When the administrator clicks Generate, the request is sent to the engine, which ultimately returns a clean SAS URI. Notice that Step 6 emphasizes the URI contains the SI equals policy name parameter, proving the linkage is successful. For our deep dive, we must thoroughly understand the revocation process. What is this? It is the administrative action of immediately invalidating a compromised or expired SAS token using our centralized policy without touching the storage account keys. How do we execute a revocation? You have 3 distinct methods. Method 1, you can delete the stored access policy entirely. Method 2, you can rename the policy by changing its identifier string, breaking the link from the token. Method 3, you can simply edit the policy and change its expiry time to a date and time in the past. However, there is a critical constraint you must be aware of for operational troubleshooting. It can take up to 30 seconds for a stored access policy change to take effect. During that 30-second window, users might see an HTTP 403 forbidden error while the system synchronizes. This flowchart maps the incident response for revocation. When you have an active SAS token in the wild and determine you need to revoke access, you move to modify the stored access policy. You can choose option 1 to delete, option 2 to rename, or option 3 to expire the date. Regardless of the path chosen, you flow into the yellow node reminding you to wait up to 30 seconds for Azure to propagate the change. Finally, the SAS token is invalidated, throwing an HTTP 403 forbidden error to unauthorized clients. To conclude our training, let us review the best practices for stored access policies. Why do we need these? Because adhering to best practices ensures scalable security and minimizes the blast radius of a compromised token. Practice 1 is the golden rule. Always reference stored access policies where possible instead of issuing ad hoc SAS tokens. This ensures you always retain revocation control. Practice 2 addresses are hard limits. Group your users logically by function, such as read auditors and write contributors, to safely stay within the 5 policy limit per resource. Practice 3 focuses on transit security. Always enforce HTTPS for the creation and distribution of any SAS token to prevent malicious interception. Finally, practice 4. Define the absolute minimum access permissions necessary within the policy, strictly adhering to the principle of least privilege. Thank you for joining this session. Our final diagram is a mind map consolidating our SAP best practices. We start with mandating usage to avoid ad hoc SAS and maintain revocation power. We move to logical grouping, grouping by job function to stay under the 5 policy limit. We enforce network security by always using HTTPS to prevent interception. Finally, we apply least privilege, ensuring the policy grants only the minimum required permissions to get the job done securely.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB730 exam, if you open it, so you can see here this and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.